All right. So on this, whoa, hold on. I have two things going on at the same time. Wow. All right. So we've got dividing polynomials. And you can do this using synthetic division, but I'll do it both ways. So, and I got to be careful of that because I told y'all in class that it had to be just x plus something or x minus something. I'm going to show you both ways to do this problem. We'll use long division first. So 2x into 10x cubed. If I divide 10x cubed by 2x, I get 5x squared. That goes up here. Now I'm going to multiply. 5x squared times 2x is 10x cubed. 5x squared times 3 is 15x squared. Now, in long division, we subtract next. So 7x squared minus 15x squared is a negative 8x squared. Bring down the next term. Now I'm going to divide this by 2x. I make it negative 4x. Multiply. Then subtract. So these would cancel. I'd have negative 4x minus a negative 12. That makes it 8x. Bring down the next term. 8x divided by 2x is 4. And then we subtract. That gives me a negative 7. That is my remainder. And the way the remainder gets written, it gets written as a fraction, that's a negative 7, over what we divided by. Now you could write it this way, or you could actually write that as a minus 7 over 2x plus 3. Negative is like having a minus, subtracting a positive. Now I did say that you could do synthetic division. So let me show how you can do that. Let me write the coefficients of my divisor. And on the outside here, it's supposed to be what makes that equal 0? That would be negative 3/2 when I solve for it. Synthetic division, you bring down the first term. 10 times negative 3/2 would be a negative 15. Add down, I get a negative 8. Multiply, I get a positive 12. It's going to give me an 8. Multiply, I'm going to get a negative 12, and I get a negative 7. So notice that the problem here is that because I did the kind of a slide thing with the 2, all of these are bigger than they should be. They're doubled as big. That's why this isn't a good one to do with synthetic division, because you would actually have to go back and divide all of those by 2. And most people would forget to do that. Now the remainder is right, but the rest of it was not. So if you don't have just an x plus something or x minus something, it really is best to do long division. Now, the next 2 are systems. And you can use either substitution or elimination. I prefer elimination. So I'm just going to multiply the second one by 2. And I'll get 4x minus 2y equals 2. Add them together. I get 5x equals 16. So I get x equals 16 over 5. Now I need to plug that in. So I'm going to plug that in into here. So That's 16 over 5 plus 2y equals 14. Now, if I'm using this calculator, I can do 14 minus, if I do alpha y equals, I can type this in as a fraction. Nice. So now I have 2y equals 54 over 5. Divide by 2. I get 27/5. So notice I did not have to sit there and work with fractions. The calculator can help me. And I'm good. Last problem. Now this is a 3 by 3 system. So we've got, this is 30, 47. Ooh, 47. X plus z equals 3. Then x plus 2y minus z equals 1. Then I have 2x minus y plus z equals 3. Now, on first thought, z's would be nice to get rid of. Yes. But I'm noticing that equation 1 doesn't have a y. So if I can think of a way to combine 2 and 3 to also get rid of y, that'd be awesome. Well, if I multiply 3 by 2, I could do that. So multiply 2 times equation 3. So if I multiply equation 3 by 2, I'm going to get 4x minus 2y plus 2c equals 6. Remember, I have to multiply the whole thing. Add. So 5x plus z equals 7. Now I have this other equation up here. And I need to use these two together. Ooh, if I just multiply that by -1, I got it. That gives me 4x equals 4. X equals 1. Awesome. Now I like the x plus z equals 3. 1 plus z equals 3. Z is 2. Now I'm going to use equation 2 to find y. X was 1. Z was 2. So now I've got 2y minus 1 equals 1. 2y equals 2. Y equals 1.